So we have learned about mass and volume so far. Mass, we know, is represented on a particle diagram by the number of particles. And as we've discussed in previous topics, this is somewhat limited, but mass in general can represent the number of particles for all intents and purposes. Now, volume, on the other hand, is the amount of space that the particles take up. So if it has a larger volume, that means it's taking up more space. So let's consider something like iron. I'll draw it in red. Iron. When we collected data on iron, we noticed that the density of that object was 7.87 grams per milliliter. Now let's consider aluminum, which I'll have represented in yellow. Aluminum, like so. It has a density of 2.7 grams per milliliter, like that. And if you remember on the graph that we generated in a previous video, we had mass, volume. This was measured in grams. This was measured in milliliters. And what we found was that the iron's slope was steeper than that of the aluminum slope, like that. And so what we can do now is use this graph and these slopes of the lines, which represent the density, to help us think about what the particles might look like. And so what I first want to do is consider what it would look like if they are equal volume. In other words, if I had one block of iron, like that big, and one block of iron, that big, equal size. So the volume is the exact same. So if I look up here on my graph, then what I'm talking about is that guy right there, that volume, is the same for both of them. So we're talking about that right there and that right there, the volume. And so you can see that the volume of the gold line, which is the aluminum, has a much lower mass than the volume of the iron. Okay? And so what that means is iron is going to have more particles because it's the number of particles. So I might draw that like so. I'll get my dot to be a little bit bigger here. I'll go 1, 2, 3, 4, 5, 6, maybe. Something like that. Then for the gold, I'm going to show less particles. Now, when drawing particle diagrams, typically it's just qualitative. It's just to help us think about it. We could be exact if we wanted to, but I don't really want to. And so I'm just going to show less dots in there. Okay? And so in other words, we have this represents equal volume. In other words, there are less particles for the aluminum than there are for the iron in equal amounts of space. Okay, now I'm going to move this guy to the side here, and that way I can compare something here. I'll move this guy a little bit. Okay, now let's talk about if there is equal mass. Okay, so instead of thinking of it like this, now what we're going to do, I'll do it in like a different color up here. I'll do green. Up here, let's say we have equal masses here. So in other words, this would correspond to that volume there, and this, whoa, I can't even intersect with that gold line, but it would be somewhere out there. Okay? So in other words, if I had equal masses, notice how the red line is going to have a much shorter, smaller volume than that of the gold line, which is the aluminum. So what I need to do when I draw my boxes is I'm going to show aluminum have a very tiny box here. And then I'm going to show the aluminum having a much bigger box because it's going to take a lot more space to have the exact same number of particles. I'm going to make this aluminum box a little bit bigger because I think you'll see why. Now I'll draw in my particles. So I'm going to do something like that for that. And then I'm going to show something like this. Boom. So notice here I've got equal number of particles, 4 in both, and over here I've got equal size boxes because it's equal volume. Now, this leads to something very important, and that is, what is density about particle diagrams? Density can be defined on particle diagrams. I'm going to write it nice and big. Density is the amount of spacing between particles. If you have a very dense forest, that means the trees are really close together and it's hard to walk through it. The same thing applies here. Iron is denser than aluminum. That's because these particles are very, very close together as compared to these particles here. Much more spacing. Same thing applies here. Notice the spacing of these guys should be the exact same as the spacing of these guys over here because the density of the iron is the same. It's the spacing of the particles. So, when drawing particle diagrams, representing mass is the number of particles, volume is the amount of space, and the density is the spacing. Now, I was going to show you one more problem here, and let's consider this. I'm going to draw 2 boxes here, like that, and then I'm going to show particles that look like this. Okay. In this object, we have 2 different things, and let's talk about how their masses, volumes, and densities compare. Let's call this A, object A, and this object B. So which one has a greater mass, A or B? In this case, for mass, I'd look for the number of particles. This is easy. B has 4 dots, A has 2, therefore B has more mass, so it's A is less than B. Now, what about volume? Volume is the size of the container. Again, B has a much bigger box, so A is less than B. Now let's consider density. Density is the spacing between the particles. And notice how the spacing here is about the same as the spacing there, and the spacing there, and the spacing there. Therefore, the density of A and B are actually equal. This is the same substance, just you have an object that is slightly bigger.